I'll have you know that Paul Dreesen and I both went to the University of Denver. I majored in physics, which is specializing in laws that cannot be broken, and he got a degree in law, specializing in laws that can be broken, especially by the people who make the laws. Anyway, I'm going to talk about the magic of climate science. I think Paul said something about how magic doesn't happen, but let me tell you, I witnessed some magic the other day. This is real magic. There's a guy walking down the street, and I witnessed with my own eyes. The guy turned into a tavern. Well, that passes for humor where I come from. Okay, we're going to talk about the magic of climate science, and keep your eye on CO2. Let's see here. There we go. Now watch carefully. This is a drawing that there's many versions of it, but it came from the 5th IPCC report. And we're going to bring in Al Gore here. One of his things where he's describing exactly how the climate or how the greenhouse effect works. We have sunlight coming in, and then it heats up the earth, and the earth gives off some infrared, but that blanket of CO2 reflects that CO2 or reflects that IR back to the earth, and we have global warming. Okay, now we're going to go on just a little bit and describe a hypothetical thing which I call the gray ball. Question is, what would the earth be like without the greenhouse effect? Well, if you take out the greenhouse effect, you take out water. If you take out water, you take out ice. You take out snow. You take out clouds. It's kind of an unrealistic thing. But the calculation goes this way, that suppose we had something, and in this case, I'll make a small isothermal ball. The reason it's isothermal is because I don't want to deal with temperature variations around the surface of the ball. It's gray, meaning it reflects exactly as much sunlight as the Earth does, which is about 30%. And on that basis, and you average over the surface of the ball, it receives 239 watts per square meter from the sun, and it radiates 239 watts per square meter to space. Now, this is all because we know what the solar intensity is at the Earth's orbit. Of course, it varies with where we are in the orbit, but we'll simply deal with the averages. Okay, and to show how this has been used, here is a slide that I stole from Scott Denning, who is a climate alarmist. There's sunlight shining on the Earth, and energy in equals energy out. So this equation, S is the solar intensity, alpha is the reflectivity or albedo, 1 minus alpha, 1 minus 0.3 is 0.7, and so forth. You calculate what the temperature is, and you get negative 18 C, but the observed temperature of the surface is about 15 C. And there's a 33-degree difference of the Earth from that of the gray ball. And this calculation was done already back in the first edition of the IPCC follies. And in terms of absolute temperature, those are 255 K and 288 K. Okay, now we invoke the greenhouse effect. And what I've done here is thrown in a super thick atmosphere just so I have room to put some stuff into it. But whoops, back up there. The surface is actually measured these days, allegedly, by, in that one graph, 289 K. And the atmosphere is responsible for that increase, because without that it would be at 255 K. Okay, so the greenhouse warming is the difference between those two temperatures, or 34 degrees Kelvin, or 34 Kelvin, 34 degrees Celsius, and that is the warming due to the greenhouse effect. Now, whether that is 34 degrees, 33, 33.79286, doesn't matter. There's some minor disagreements at the margin, which have nothing to do with the overall conclusions. This is not controversial. There's no trickery in this calculation. In fact, what I'm going to do is to be using numbers that the IPCC is very happy with. But we're going to practice a little bit of intellectual jujitsu. In other words, we're going to use their arguments against them. Okay. Now we have what's called the radiative forcing. And as far as I can see, the only place this equation was ever presented was in the third edition of the, let's see, the TAR stands for Third Assessment Review, or something like that. And then after that, it became AR4, AR5. Anyway, here's a simplified expression, and the top line there says that delta F, which is called the forcing, is alpha times log, that's natural log, C over C0, and alpha is 5.35 in watts per square meter. Okay, so for a doubling, C over C0 is 2. The logarithm of 2 is 0.69315, as you all know. And so that gives us 3.7 watts per square meter for doubling CO2. Okay. More recently, evidently, what I get from the scuttlebutt is that it's they've changed that formula from 5.35 to 5.05, and it will be 3.5 watts per square meter. Again, the conclusions we'll come to will be robust, rather independent of the small decimal point there. This is another thing from Scott Denning. He shows a 4-watt light bulb, and he says doubling CO2 would add 4 watts to every square meter of surface on the Earth 24/7. Doing that would make the surface warmer, and this was known before light bulbs were invented. Well, indeed. People understood that a long time ago. But anyway, there's your global warming. Whether that number in watts per square meter caused by doubling CO2 is 4, 3.7, 3.5, 3.0 watts per square meter, that may be a little bit subject to question, but not an important one. Denning rounds that then accepted value up to 4. That bit of exaggeration is, it's important, but it's not the magic trick. Now we're going to get around to a little bit of discussion of where this global warming hype is coming from. Authority by computer. I don't know how many students have told me, but that's what my calculator said. You know, complicated computer programs can be based on things that aren't correct, or they can have incorrect programming in them. Fortunately, Microsoft, with thousands of highly competent, brilliant, I mean that seriously, programmers has never made a mistake. NASA says, here we've got NASA and the urgency, the new urgency of climate change. Harvard says, Harvard scientists, we have 5 years to mitigate the worst of climate change. The UN says we have 12 years to limit climate change, blah, blah, blah. Now, I don't know where in heck they came up with these pictures. The chap on your right there is Will Happer, who was appointed by Donald Trump. And I don't know why you'd appoint Will Happer. I mean, Will, he gave a talk here last year, and you know, he's only got something like 4 decades of experience with atomic, molecular, and optical physics and all that stuff that deals with the interaction of infrared with molecules and so forth. You know, he could have hired John Kerry. Anybody ever heard look up anything on Babylon Bee? It's a very, very funny satire. I get a kick out of it. Anyway, you're going to have to wear masks to prevent global warming. Okay, a problem with appeal to authority is it's a logical fallacy. You know, what matters is what happens, not who says what. But science has experts. No authorities. We don't have authorities in science. And it serves as a diversion. People get to talking about personality and we don't really understand the science. So let's go on and now extend this little drawing that I had before just 1 notch. The effect of the atmosphere is to change the nature of the Earth so that there is the atmosphere with the greenhouse effect and all atmospheric things combined. I mean, it's a lot more complicated than just the greenhouse effect. But the long and short of it is that the Earth is something like 34 degrees warmer than the effective gray ball. But this drawing actually brings us dangerously close to hypocrisy. Are you ready to be a hypocrite? Right in there. Because what we have in that circle is that because the Earth is at a temperature of approximately 289 K, it radiates 398 watts per square meter. Yet the Earth as a whole radiates 239 watts per square meter to outer space. Okay? That isn't quite hypocrisy yet, because that's right there on one of their drawings. Hypocrisy will come later. Anyway, here's a picture of Al Gore on a graph of nothing versus nothing, showing a bunch of demons going around the Earth, and he's talking about the effect of carbon dioxide on the Earth. And the left part of that graph there is showing a very dramatic increase in the effect of CO2 in terms of how much radiation it blocks as a function of the concentration of CO2 in the atmosphere. But here's what the whole graph looks like. Even at very, 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 very low atmospheric CO2, I mean like 10% of what we have in the atmosphere, CO2 does a pretty good job of blocking out, stopping the IR in that particular band. And by the time you're up to about 200 or 150 or so parts per million, it isn't saturated. It doesn't come out quite flat, but you reach a region where there's not much change. And it turns out that each doubling gives you the same amount of blocking, of additional blocking, according to that logarithmic formula. So I'm going to show you that what I am talking about is perfectly, what did you say, sacred, IPCC stuff. Look at this graph again. Again, this is a chart showing the various mechanisms by which heat goes into the atmosphere, out of the atmosphere, down to the surface, blah, blah, blah. But most of these things are internal processes. It's about like paying attention to how the heat goes from one feather in your pillow to another feather in your pillow, if you have the pillow over your head or something like that, I don't know, or a blanket. Those are internal processes. What matters is, if you'll take a good look at that, 340 minus 100 is 239, right? I mean, given the uncertainties. You have 239 watts per square meter in, 239 watts per square meter out. However, the surface is emitting 398 watts per square meter, which is what I had in the other drawing. So what I showed you in the other drawing is pure ICC truth. Okay, but now we come to heresy. This is called heresy by subtraction. 398 watts per square meter emitted by the surface minus 239 watts per square meter emitted by the Earth to outer space is 159 watts per square meter. Now that 159 watts per square meter is circulated back and forth through the atmosphere, down to the Earth, up to the atmosphere, evaporation, rain, snow, hail, everything. It's just all internal stuff. But the long and short of it is that the overall greenhouse effect is 159 watts per square meter. Okay, that's heresy. We have subtracted, and you'll see why it's heresy in a moment. 159 watts per square meter of heat retention keeps us, what, 34 degrees warmer than the gray ball. Do you agree? That's what they say. And I'm not going to quarrel with that, because I can do the calculations myself. Okay, or maybe it's 150, maybe it's 160 watts per square meter. Again, this conclusion is robust. It doesn't depend on the last digit. Maybe it's 33 degrees, maybe it's 34. We're just going to allow a little bit of slack here. Now we come to heresy by, are you sure you want to be heretics? Heresy by comparison. Doubling CO2 concentration from 400 to 800, or if we went from 415 to 830, it would cause a radiative forcing of 3 watts per square meter. 3.5, my mistake, your fault. Now do you see the trick? 159 watts per square meter keeps the Earth 34 degrees warmer than the gray ball. The radiative forcing, in quotes, from doubling CO2 will add 3.5 watts per square meter, a mere nudge to the total. So you have 159, you add 3.5 to it, you get up to 162.5. That is an increase of 2.2%. Take that to the bank. Doubling CO2 will add 2.2% to the total heat retention. Now you're becoming heretics. Of course, I knew you were that when you got in here. The heresy is to make the comparison between the 3.5 watts per square meter and the 159 watts per square meter. And it is also to notice that the dramatic sounding radiative forcing is just a nudge. Now we'll go back to Mach 3, the third version of the big picture. In the left we have the gray ball, and in the middle we have the atmosphere around it, which is 34 degrees warmer. It radiates 239 watts per square meter to outer space. All planets radiate the same amount to outer space as they get from the sun. But the surface radiates 398 watts per square meter, the difference being the 159. Now, if we double the CO2, the picture changes very slightly. The surface will radiate 401 watts, 401.5 watts per square meter, but the Earth as a whole will radiate 239. Another view of that, again, none of this is controversial except that lousy subtraction we did. The numbers all come from the IPCC. On the left we have 159 watts per square meter. That much heat retention causes 34-degree rise above the gray ball temperature. Okay? Now, a couple of quick calculations. One of them is we're going to say, well, if the heat retention goes up 3.5%, how about increasing 34 degrees by, 2.2%, whatever it is. We wind up with a 0.75 degrees C warming. Okay? The more accurate calculation would involve the Stefan Boltzmann radiation law, which I write for formality. The physicists are busy watching to make sure that I've done the logarithmic derivative correctly. But the long and short of it is that the temperature rise using the correct physics would be 0.64 degrees C. Okay? That's all basic physics. Now, what happens when we go to 800 parts per million instead of 400? By the way, ppmv means part per million by volume, but could also mean parts per million by the count of molecules, by the number of molecules, which is the way they actually do it. Anyway, the CO2 doubling would add 3.5 watts per square meter. Climate science, meaning the IPCC, says that 2.2% nudge in heat retention will cause an 8.8% increase in the above the gray ball temperature. In other words, they are saying that it's going to be 3 degrees of warming, which is 4 times the 0.75 you'd get from the simple-minded but not so good calculation, and even higher if you use the correct calculation. Okay, well, what's a factor of 4 among friends? Now I'm going to show you a different one here. The IPCC says that the climate sensitivity is, which climate sensitivity means how much would the temperature rise if we doubled the CO2. And that's, this kind of crazy vocabulary diverts your attention from the physics. And anyway, 3 degrees of warming is 4 times what you would expect from the simple linear model. There is really a kind of a better calculation to do too, and that is to say, well, what happens if the temperature rose 3 degrees, which means instead of 289, it's 292 degrees Kelvin. Calculate how much heat would need to be retained, and you find out it's somewhere around 16 watts per square meter. And that's going to come from 3.5. Okay, anyway, pay attention to your authorities. Don't be heretics. The graph on the left shows what's called a spaghetti graph, a whole bunch of graphs of people who are following the science. And as a function of time, it is showing, what their models say for the present and what they say for the future. And then those little arrows there with the boxes tell you what the vocabulary was at the IPCC. Back at the first model, they were confident in the results. The second report, they had increased confidence. The third report, they were likely to be right. The fourth report, they were very likely to be right. And the fifth one, they were extremely likely to be right. Okay, so this is a little chart that's from the latest AR5. A 0.75 degrees C is indicated by that red arrow. 0.6 would be a little bit to the left of it. But that dark red arrow in the middle is kind of the canonical view that there would be 3 degrees of warming, between 1.5 and 4.5 degrees of warming would come from doubling CO2. And you can see that doesn't make just a whole lot of sense. But wait, there's more. What about the knock-on effects? Now you got to understand, right here, you got to understand this, that the CO2 contribution is very, very small. Okay? Very, very small. Everything that is the source of the screams and the hollers that you have heard has come from what's called positive feedback, where you have these knock-on effects, and I'm going to go over some of these things. If you melt some snow, you expose the dark soil, which will absorb more light and therefore heat up the earth. And it would decrease the albedo, and my golly, so the earth is going to absorb more sunlight. And if you melt permafrost, you release methane, which is a greenhouse gas. And people, oh my God, that's terrible. And if you warm the planet, it warms up, you get higher humidity, and thereby you increase the greenhouse effect. So those are the knock-on effects. You get positive feedback, and from that you get all these disasters. And you'll notice here, I got this little chart from Wikipedia. They've got the feedback thing in there covering snow cover, and they could say ice as well. Atmospheric water vapor increase and permafrost melt, and the effects on the environment, habitat destruction, intensification of extreme weather events, and let's see, what else? The glacial retreat, ice sheet melt, coral bleaching, etc., etc., etc. All this is caused by the feedback effects. But you've been hooked. Well, I'll get to that in just a second. Anyway, there's a sixth report that is coming out, and I looked up that sixth report, and there's something about it. I looked at the screen, and I couldn't read a single word because the thing was printed in black letters on dark blue, and so I think they're kind of embarrassed by their own failures, or at least I hope they are. On the other hand, they like to brag, and they have this wonderful graph of nothing versus time, which makes it kind of a silly graph, but it will impress the stupid but numerous. Now, we're going to counter the big lie. Tell me, did anybody ever see anybody else refuse to put ice in their Coke because the CO2 would melt the ice? Anybody? No. CO2 does not melt ice or snow. Heat does. You knew that. CO2 does not evaporate water. Class? Heat does. CO2 does not melt permafrost. Class? By golly, what a great class. Okay, so those knock-on effects that they're talking about are in no way caused by CO2. They are caused by heat. Now, we've seen that there's a factor of 4, right? There's doubling. We talked about doubling CO2, and there's a factor of, it's actually more than 4, but how much heat generates how much more heat. So now you simply imagine that there is heat from some source, could be anything. Any source of heat whatsoever. It could be from a stochastic process, a systematic process. It could be CO2 increase, solar increase, cloud decrease, vegetation variations, ocean current variations, all these things we call weather. You name it. Any source from any heat whatsoever can melt snow and ice, evaporate water, melt permafrost, and thereby cause all those nasty climate change disasters. I'll hit all those tipping points that they advertise. So here's the amplification mechanism. Now imagine that there's just a small variation somewhere, like a milliwatt per square meter, and someplace on Earth it melts a little bit of ice or evaporates a little bit of water. Evaporated water causes some permafrost to melt and so forth. But the long and short of it is that there's a factor of 4. So 1 milliwatt per square meter begets 4. 4 begets 16. This is because heat is causing heat. 16 becomes 64, becomes 256, becomes 1024, 4096. 4 watts per square meter gets 16 watts per square meter, on and on and on it goes. Heat causing more heat with these alleged positive feedback mechanisms. This happened a few times the past billion years of the Earth. Somehow the Earth hasn't heated up. Those tipping points haven't occurred. Well, the garbage in, garbage out models say they will occur. But now this one is just a sort of a simple final graph on this part of the talk. Something is missing here. I wanted to have, and I was too stupid to put in, a dotted line going across the graph there at 130 watts per square meter, and that's all things constant except CO2. Okay, now down at the bottom There's no heat retention in the gray ball. When we add some CO2, it comes up rapidly to somewhere around 30 watts per square meter and then kind of quasi flattens out. It's that logarithmic thing. But the total heat retention is up there at the top. Imagine that line at 130. Now, it is not controversial that CO2 is responsible for 20% of the greenhouse effect. Okay? This is not controversial. So, that's the effect of doubling CO2 from going from 400 to 800. And that little bit in there, that 3.5 watts per square meter, is going to cause heat waves, rising seas, droughts, floods, etc. Read your papers. That's all in there. There are literally thousands of things that have been attributed to, in quotes, climate change. Okay, what's in a name? 159 watts per square meter is the total blocking effect or the total greenhouse effect of the Earth. Okay? Climate scientists have no name for that. But that little nudge of 3.5 watts per square meter is lovingly called forcing. You see how you've been schnookered by terminology that's kind of terrible? Such is the magic of climate science. In quotes. I'm going to talk about another feat of climate science magic. Here's the head Goron walking in front of a large graph of CO2 and temperature versus time. And he's pointing out, well, his graph goes 700,000 years. I haven't been able to find anything that went back more than 400,000. That's good enough for the kind of people I run around with. Anyway, he's pointing out this strong correlation there. And now, this is a graph showing the last 400,000 years. And I want you to concentrate on the correlation. Look how the temperature goes down and the CO2 goes down, and then the CO2 comes up and the temperature goes up. It goes on and on and on. Your eyes are getting heavy, your eyelids, you're falling asleep. Just don't ask where the CO2 came from. Those oscillations are due to Milankovitch cycles, which has to do with the variations in the Earth's orbit. I won't go into all that. Tell me how those variations in the orbit, the tilt of the axis and all that kind of stuff, tell me how those affect CO2 in such a way that they subsequently affect the temperature. Has anybody ever seen a paper giving such results? Well, I won't raise my hand because I haven't. I haven't seen any paper whatsoever saying how the Milankovitch cycles cause the CO2 to change first and the temperature to change second. They provide no mechanism for it. Okay? Don't ask where the CO2 came from. Don't ask where it goes. Have a good read. We have terabytes, literally terabytes of horror stories on the internet, in the newspapers, and NPR, and CNN, and ABC, and CBS, and on and on and on and on it goes, about climate, climate horrors and so forth, and it has infected the science journals, much to my dismay. You can fool some of the people all of the time, and all of the people some of the time. And that's enough to set up a multi-billion-dollar climate crisis industry. And with that, I thank you.
You mentioned the increased water vapor, the increased CO2, the slight increase in temperature, increasing the water vapor, which is a greenhouse gas. My son mentioned that, well, with the increase in water vapor, you also have increase in clouds, which will reduce the heating.
I don't quarrel with that at all. I'm just saying what they take as positive feedbacks. Yes, it will.
Thank you, Howard. Following up on that, since you're on the board of the SEPP, Science and Environmental Policy Project, and I think Ken is here too.
Yeah, Ken is here.
Anyway, over a year ago, there was a controversy in the weekly newsletter sent out, and I forget who it was, posted some facts about the radiative forcing and the variation from one year to the next. And I think it was from one year to the next, but for carbon dioxide, it was on the order of 0.02 watts per meter square, but just clouds alone, variation was 2%, 100 times as much. And as you were saying, you know, there's no reason why carbon dioxide could cause a temperature to change, but as your predecessor Fred Singer and Dennis Avery demonstrated in their global warming every 1,500 years, that increased heat is what drives the carbon dioxide out of the ocean. So there's one question there. What's your conclusion about how cloud coverage and the variations in that are just totally left out of the IPCC calculations? And then someone was pointing out that the error bars just from the clouds would just overwhelm the error bars from changes in carbon dioxide. But then there was controversy. A lot of people wrote in, and those were published, that no, that was misleading. But I didn't follow the objections. So what's your take?
Well, my take is that on a short-term basis, it's absolutely the case that the variations in cloud cover would swamp any variations due to CO2, because CO2 has a seasonal variation that's pretty small. There is a much bigger variation, which is due to the fact that the Earth is a good deal closer to the sun in January than it is in July. And there's another thing that pertains to the heat, and that is that when we are having a northern winter and they're having the southern summer, we're closest to the sun, but the southern hemisphere is mostly water. The sunlight comes in and heats up the water down to great depths so that the temperature change is not very big. And so under those circumstances, we are absorbing more energy than we are emitting it. In the northern summer, just the opposite happens. So in the northern summer, the sunlight heats the Earth quite a bit rapidly, and it radiates more into outer space, in a kind of a big hurry. But on year-long average, it's somewhere around little 0.7 watts per square meter is their ability to detect. But anyway, it's kind of hard for a physicist who doesn't deal with clouds, although I dealt with a lot of people with heads in their clouds. I just have no concept of what long-term cloudiness looks like. But on a short-term basis, it's absolutely the case that the radiative flux simply caused by a change in reflectivity would be rather large compared to the CO2 thing, yeah.
Just a question. It seems to me that if you double the amount of CO2, much of it will be more absorbed by plants and plankton in the water and so forth. So is that 2.2%, take that into account, or is that just an absolute physics number, and then in reality it would be even less because of the immediate reabsorption of CO2?
Well, it's based on the notion how much CO2 is actually in the atmosphere, and it's a net effect. I mean, it is not widely understood exactly, I mean, by journalists and politicians, but I repeat myself. What happens? CO2 absorbs an infrared photon, okay? Now it's excited and it's spinning or vibrating and so forth in the way that it vibrates. So it has some excess energy, but it has a couple of ways to get rid of that excess energy. One of them is by collisions, and the other is by radiating, and it radiates in a random direction. On the other hand, just because of statistics, and for the mathematicians amongst you, it goes like e to the minus energy over kT. There's certain populations of excited CO2 molecules in a temperature-dependent way. In other words, at room temperature, something like 2% of the molecules are in that excited state. It's, it's temperature equilibrium kind of thing. So if CO2 radiates, it kind of cools down, but the other molecules come along and they bounce into it and they cause that excited state to occur. Up in the upper atmosphere, where the CO2 has a good chance of escaping into outer space, and the temperature is about 220 K or something like that. Additional CO2 causes additional IR going out to outer space. So it has a cooling effect, which is not as great as the warming effect near the surface, but they're both kind of small. Yeah.
I was trained in meteorology and physics and math.
Great.
And I've used a lot of the things you've been talking about today, time and time again. And I love what you've said. I just want to say thank you. You've done a good job.
You're quite welcome. Thanks for the compliment.
So you're calculating that a doubling of CO2 is going to raise the temperature 3/4 of a degree C, and the IPC is calculating it's 3 to 4 degrees C. What's the historical record show for a doubling?
Well, we haven't actually had a doubling, have we? We've had a lot of fluctuations and so forth, but they get all of that 3 degrees or so, not from CO2, but from the knock-on effects. And what the temperature actually does, I mean, it's a funny thing. Over a long period, you can say there's a certain average temperature, and you can say there are some variations in that. Those variations are absolutely minuscule compared to the day to night variations or the summer to winter variations, you see. And so there are always going to be short-term fluctuations that are huge compared to to the long-term variation. And so it's really hard. I mean, the Earth has been warming up according to the satellite data, except for the last few months it's gone down, fairly considerable amount. But it's really hard. It's hard to determine long-term fluctuations. The climate is normally taken to be 30-year averages. And we don't have any 30-year averages of what the climate was like 8,000 years ago. We just don't have the fine resolution there. But anyway, the climate varies so much over a short period of time. My present age is 3 to the 4th, so I have seen not quite 3 data points on the climate graph. Not quite 3 points on the climate graph. And whatever point I may have seen, well, let's see, I spent my first approximately 30 years in Colorado, and then the next approximately 30 years in Connecticut. So I have 1 data point here and 1 data point there. What do you make of that? I don't know. So, sir.
Would you help us understand a little bit in communicating with the publics about the difference between Celsius and Fahrenheit? In other words, I took your data, 37.4 degrees Celsius is, 3 degrees Celsius is 37.4 degrees Fahrenheit.
I'm glad to do that. I'm glad you asked that. A temperature is not the same as a variation in temperature. For example, the 0 of the Celsius scale is the freezing point of water. The 0 of the Fahrenheit scale is what we normally call too damn cold. So they don't start at the same 0. So the way you calculate it is that there's the freezing point of water in Fahrenheit is 32. The boiling point is 212. So there's a 180 degree span between freezing and boiling. In the Celsius scale, there's 100 degrees between the two. So the size differential, or the size factor, is 5/9 or 9/5, depending on which way you're going. So if you want to convert the 3 degrees Celsius into Fahrenheit, you multiply by 9/5. So 9/5 times 3 is 27/5, which is about, 5.4? So that'd be 5.4 Fahrenheit increase. But when you're comparing the temperatures, you have to account for the fact that there is a 32 degree difference between freezing in the Fahrenheit scale and 0 in the Fahrenheit scale. Does that clarify the matter for you? Yes. I hope it's right. So, incidentally, for you medical people, you've been told since time immemorial that the body temperature is 98.6. That is an exact translation of an approximate number, namely 37 Celsius. And you probably, all of you in the medical profession know that that number is too high. It's more like 98.2, I think. Is that correct? Anybody dispute me? Yeah. Okay. Well, thank you very much.